All right, and the second objective we're solving, the first thing you're going to want to figure out is if you're going to have to loop. So I'm going to look at the whole page first, and I'm going to highlight the problems where there's a constant, and I'm going to have to loop. So when I look at the first row, there's a constant on 14 and on 15. In my second row, 16 has a constant, 18 has a constant, so I'll be looping. Nothing on the third row. Constant on 21, I have to loop. 23, I guess we'll see once we set it up, and that's it. The rest of them I won't have to loop. If you don't have to loop, so for instance on 13, and we are working with exponents, your job is with your exponent table, which is attached to your review, is you want to see what row has both an 8 and 16. So for instance, on your exponent table, if I were to look for the row that has both an 8 and a 16, it's this row. And the number that's all the way to the left, this column, this is your base number. So 2 to the third power gives me 8, and 2 to the fourth power gives me 16. So that's how I'm going to alter that problem. So 2 to the third power is 8. 2 to the fourth power is 16. Haven't changed it yet, just the way it looks. And then I still have the 5x with the 8, and I still have the 3x plus 4. And I'm going to put those in parentheses because those parentheses are going to tell me to distribute. So now that these bases are the same, I can basically ignore them and focus on the algebra problem. So the left side is going to become 15x. The right side is going to be 12x plus 16. And now to solve for x, I'm going to have the 12x join the 15x by subtracting it. At this point, I have 3x, and on the right side, I still have the 16. And now what I'll do is to solve for x is I'm going to divide by 3. So when I'm done, x is 16/3, which you can write that. You can also write the decimal version and to go 3 decimal places if you do that. So that is problem 13. 14, I have a constant, so I'm going to loop. Now remember, you start with the base and you loop towards and you go around the equal sign. And don't forget, you're looping it into a log, not back into an exponent. So the base of the problem is 16. That's going to become the base of the log. Then I go towards and around the equal sign, and then that will equal my exponent. Now, some of you are going to be at the advantage here because of your calculator, and you can just type in that log. But if you can't, then you have to go back to the formula that's highlighted in green at the top, and you're going to have to use that change of base formula. So I will show that for those people. That means I'm going to have to take log, or I could use ln, of 64. Don't forget, you would have to close your parentheses on your calculator. And I'll divide it by log of 16. And that equals the 9x plus 3. When I'm done, that log 16 of 64, however you figure it out, is worth 1.5. That's with the 9x plus 3. Now I'm going to work to get the x by itself. So first I'm going to subtract 3. That turns 1.5 into negative 1.5. And my last step is I'm going to divide by 9. So for this one, I actually am just going to put the decimal version. So negative 0.167. That's what the negative 1.5 is divided by 9. All right, 35. I have a constant. I'm going to be looping it, but I can't loop it until it is just the log. So I will have to move the 35 first, and I'm going to move it by dividing it. And I'm just going to leave it as a fraction, but now I'm ready to loop into an exponent. There's your loop. So it goes 6 to this power equals x. And when you type 6 to the 18 over 35th power, you will get 2.513 as your decimal when it's rounded. All right, let's take a look at 16. So I'm going to have to do a little racing here so you can actually see 16. Again, we highlighted it because there's a constant, but I can't loop until it's just this log. So I have to move the 3 and the 7. I'm going to move the 3 by adding it to the other side, which is now 18. And now I have to move the 7. Since it's multiplied, I'm going to move it through division. And now I'm ready to loop it. So it loops into an exponent, so it'll be 5 to the 18 over 7 power, and that will equal x. So once you type 5 to the 18 over 7 power, you'll get rounded to 3 decimal places, 62.712. All right, let me do a little erasing for 17. So on 17, there is no log, and I probably should have made a note on it like I did on 20, but we have to get it so it's 1 log on one side of the equal sign, 1 log on the other side of the equal sign. So I am going to have to condense the left side from 2 logs down to 1. And I'm actually going to do a little more erasing. So when I do that, the first thing I'm going to do is the left side. This is just condensing, which we did on the first objective. So it's going to go um, 10 squared, and then minus x to the 1/4. I'm just turning anything that's multiplied back into an exponent. And now that subtraction is going to become division. And now I'm going to write it as the fraction that we're used to seeing, with the log going back with it. Now, 10 squared, you guys, that's 100. So at this point, I'm just going to write 100, and then divided by x to the 1/4. And now I have the log on the other side. Since I have 2 logs that have a common base, since the bases are the same, what I can do is just ignore the bases, or ignore the logs of their bases, and just focus on this. Now, whenever I have a fraction and I'm asked to solve, what I do is I just make it 2 fractions, and then I use what we call cross products. So I'm going to take 100 times 1, which is 100, 50 times x to the 1/4, which I'll just write out. And now I'm ready to solve for x. First, I'm going to move 100 by dividing by 50, or I'm going to get x by itself by moving the 50. I'll divide by 50. And now to get rid of the 1/4 power, I'll have to take this side to the 4th power, which just makes it x. And I'll have to take the 2 to a 4th power, which is 16, not 8. So when you're done, your answer here is 16. All right, 18, we're going to be looping because there's a constant. It's not quite ready to loop yet because I need just the base and the exponent. So I'll have to move the 4 first. So I'm going to move it by adding 4. And now I'm ready to loop. And again, it's an exponent. You loop it into a log. Don't forget the log. Some of you can type that into your calculator. If you can't, remember, in the change of base formula, it's just log 9 over log 3. That log 9 over log 3, or if you're able to type it in directly, that is worth 2. And now to get x by itself, I'll just divide by the 0.1. So when you're done, x is 20. All right, let's go to 19. 19 has no constant, and it's already set up so that 1 log's on one side, 1 log's on the other. And since they both have a base of 5, I can ignore them. And I have a basic algebra problem. I'm going to get my x's to one side, so the 2x is going to join the 3x by subtracting it over, and we're done. X is 5. Very short problem. Now on 20, I did tell you to condense. What I should not have put there is this factor to solve. That's not correct. So hopefully we'll have already made that correction as you're looking at this problem. So on 20, what I'm going to do is on the left side, I can only have 1 log on one side and 1 log on the other side. So I'm going to have to take this left side and condense it down. So ignoring the logs, I start out with x plus 6 minus x. That subtraction is going to turn into division. I'm going to write it as a fraction now. That's condensed. I'm going to bring the log back. And here's the right side. And now that I have one log on one side, one log on the other, and their bases are the same. All right, sorry about that. I was interrupted, so I put you guys on pause. All right, now that I have a common log between the two, I'm going to ignore the logs and just look at what's left. And again, just like the problem before, when I have a problem that involves a fraction and solving, sorry about that, I'm going to use the cross products. So 2 times x is 2x. X plus 6 times 1 is just x plus 6. I'm going to have the x join the 2x, so when I'm done, my answer is 6. So there was no factoring here. All right, almost done. 21, there's a constant. I will be looping it, but I'm not going to loop it until it's just the space and the exponent. So I'm going to move the 1 over 32 to the other side. And to move this fraction, I'm going to multiply this side by the reciprocal, which just makes it 2 to the x. And I'm going to multiply this side by 32, which makes it 1024. And now I'm going to loop it. Remember, it's an exponent, so you loop it into a log, not back into another exponent. So here's the loop. So this 2 base is the log's base. And now some of you can just type this into your calculator. Some of you can't. So you would need to do this change of base formula. And that, either way, as you type it into your calculator, is worth 10. So x is worth 10. Now, I'm going to pause for a second because some of you are not probably pushing any buttons on your calculator. You should be practicing this button pushing because that's a big thing that's going to get you the right or wrong answer. I won't be pushing the buttons for you during the test. So you should see, can you type in log 1024 over log 2, or can you type in log 2 of 1024 through the math button and get the right answer? If you're not pushing any of the buttons, you need to start doing that or rewind and do a little bit of practice. All right, 22. I've got 2 logs on one side. There's no constant, so I won't be looping it. But I need to have it so it's 1 log on one side, 1 log on the other side, so I will need to condense this left side. So I'm going to condense this left side first, just ignoring the logs and moving that half back as an exponent. That subtraction becomes division. And now I'm going to write it as the fraction that it needs to be. And here comes the log back with the log on the other side. And now that it's 1 log on one side, 1 log on the other, they're both the base of 7, I can ignore the logs and just focus on what's left. And again, I have a fraction. Easiest way to solve it is to do cross products. So 3 times 2 is 6. X to the 1/2 is, times 1 is x to the 1/2. And now to get x by itself, I'm going to square the right side, which means I'm going to square the 6 as well. So when I'm done, my answer is 36. All right, final problems on the solving. So on 23, to figure out which of those formulas, again, on this side that I would need to use, I'm going to read it. So if John invests $2,300 in a savings account with 9% interest compounded continuously, that tells me it's the PERT formula. How long will it take John to have a balance of $4,150? So I'm going to start by setting it up, which is the initial amount. E, the rate is 9%, so there's 9% as a decimal. The time, we don't know, but when I'm done, I should have this as my balance. So I will be looping it because there is a constant, but I can't loop it until it's just the base and the exponent. So I'm going to have to first move that 2300 to the other side, and I'm going to move it by dividing it. So once I divide it, the left side is just the e with the exponent, and the right side as a decimal to 3 places is 1.804. And now I'm ready to loop it. So it's going to loop into a log, again, not back into another exponent. So I'll write the word log. This base of e is this base e. And I'm going to finish the loop. And then I'm going to remember that log e is just the ln button on the calculator. And then when I type that into my calculator, I get 0.59, and then it's actually 0 if you round it to 3 decimal places. And now to get t by itself, I'll divide by the 0.09. And when I do that, I get 6.56. So a little over 6.5 years. All right, final problem. There's no constant, so I won't be looping, but I can't solve until it's 1 log on one side, 1 log on the other. So I will have to, again, condense this side down. So ignoring the logs, the 6 plus 2x to the second power will become 6 times 2x to the second power, which is 12x to the second power. That's condensed. I'm going to bring my log back. And now, since the bases of the logs are the same, I can ignore the logs and just solve with what's behind them. So to get x by itself, I'm going to move the 12 first by dividing. Well, it gives me 4. And now to solve for x, I'm going to square root, and I'll write down plus or minus 2. That is the solving objective. So next we will go to the graphing objective.